my name is Amita, and in this video I'm going to discuss about one more commutation technique, that is the class E commutation. I know that you are aware about the commutation, but in case if you are not aware, I just want to tell them that commutation is a process by which we can change the state of a SCR or a silicon control rectifier from forward conduction mode to forward blocking mode. That means it is a process of turning off an SCR. Dear friends, there are a lot of commutation techniques are available. One is the natural commutation, another is a forced commutation. Natural commutation technique we use when the SCR is fed by a AC supply, because AC by nature it passes through zero in 2 times in one complete cycle. And when it passes through zero after completing its positive cycle and enters into the negative cycle, at that time the SCR experiences the reverse voltage, and if the load is resistive, at the same time the current flowing through SCR will be zero. That means both conditions to making the SCR off: one, it has to be reverse bias; another, the current flowing through SCR should be zero. These two conditions are fulfilled and the SCR will off. That kind of commutation is called as a natural commutation. But when the SCR is fed by DC supply, and if you want to make the SCR off in a AC side, if you want to make the SCR off in positive half cycle of a AC itself, then the kind of commutation required, that is called as a forced commutation. Forced commutation can be of two types. One is called as a voltage commutation, another is called as a current commutation. Voltage commutation may we create artificial conditions by which we try to appear the voltage across the SCR in a reverse bias condition for a sufficient duration. That kind of commutation is called as a voltage commutation, and this reverse voltage we can develop across the capacitor. Similarly, when we try to flow the current through SCR in a reverse bias condition, and the instant at which the current flowing through SCR is zero, that kind of commutation is called as a current commutation. In this video, I am going to discuss about one of a forced commutation technique, that is a class E commutation. So now I am sharing my screen where I will brief you the class E commutation. So if I discuss about class E commutation, the very important thing about it that it is a type of forced commutation technique. Why it is called forced commutation technique? Because forcefully, with the help of some external circuit, we create the favorable conditions to make the SCR off. Second thing, it is a forced commutation, maybe it is a voltage commutation technique. What kind of commutation is there? That's a voltage commutation. And the third thing is, it is also called as an external pulse commutation. Why it is called external pulse commutation? Because in this kind of commutation, the circuit which we are using for the commutation purpose, that has been fed by the another supply. That means normally in a voltage commutation or a current commutation technique, the same source which we are using in the power circuit, the same source we use for the commutation circuit also. But here we use a separate source for the commutation circuit. That's why it is called external pulse commutation circuit. Now let us discuss about its power circuit diagram. I am drawing its power circuit diagram. This is plus minus Vs. This is your main SCR T1, and here this is load. So this is the part of the main circuit. And let me draw the commutation circuit by the separate color. This is TA. Here it is capacitor, and here it is L. This is C, and this is fed by an additional source that is called as an auxiliary voltage. So you can see the circuit which I have drawn from the white color, that is the power circuit, and the circuit which I have drawn by the yellow color, that is the part of a commutation. Now let us try to understand the process of a commutation. So let me draw the circuit. During normal condition, the current is flowing like this. So this is your load current. Again, the assumptions are load current is constant and continuous. Now let us try to understand its operation. So operation में mode 1 which exists from 0 to T2 T1. So what will happen? Mode 1 mein T1 is conducting. So like this. Here it is load. TA is off and this is capacitor voltage. Here L and this one is plus minus VA and this one is plus minus VA. Now under the condition, there are two currents flows. One is this I0 and another here the current will flow like this and that is IC. So what will be the values of these current? I0 will be, as we have taken assumption that it is constant and continuous. So Vs by Z. What is Z? Z is load impedance. And second current is IC. And as this current is flowing through LC circuit, so what will be this? VA root C by L. Suppose this value is C, this value is L, sine omega t. And when this charging current is flowing, the voltage across capacitor will be calculated by this formula 1 by C integration IC dt, integration from 0 to t. And this if you calculate it, it will come as Vs 1 minus cos omega t, not Vs, Va 1 minus cos omega t. Okay, so that means when this charging current will flow, the Vc will change its value like this. Okay, so if so this is how the capacitor voltage is going to change. Now, if I plot this charging current, you can see the charging current is flowing like this, 0. The peak value will be Vs root C by L and this is suppose omega t. So at 180 it is again 0. So when this kind of charging current flows, the voltage across capacitor, you can see here at 0, if I put omega t is equal to 0, what is cos 0? 0, 1, cos 0 is 1. So 1 minus 1, what is 0? So that means capacitor voltage will be 0. But when I put omega t is equal to 90, 90 means cos 90 is 0. So means the voltage will be VA. When I put omega t is equal to 180, so cos 180 is minus 1 means the voltage will be 2 VA. That means it will change its value from 0 to 2 VA. Means by the end of mode 1, so this is something about I0 will be Vs by Z. TA is off because this positive voltage is making this TA reverse bias. And there is a one more circuit, closed circuit is there through which a charging current is flowing. So charging current expression will be VA root C by L sine omega t and capacitor voltage expression will be VA 1 minus cos omega t. That means by the end of mode 1, what will be the situation of the circuit? So at the end of mode 1, what will be the behavior of the circuit? T1 is still conducting. Plus minus, this is load Vs, the current is flowing like this, I0, TA is off, the capacitor is now charged with upper plate positive, lower plate negative and it is charged by a voltage of 2 VA, L and this is plus minus VA. Now in this case, IC is now 0 and VC is charged by a voltage of 2 VA. Now you can see here with this capacitor voltage, now the TA is forward bias as the 2 VA is greater than Vs. So TA is now forward bias. So this is the scenario of the circuit at the beginning of, at the end of mode 1. Now let us talk about mode 2. So what we do, mode 2 mein we give triggering pulse 2, TA, as TA is already forward bias at the end of mode 1. So T1 load. Now as soon as we give the triggering pulse to TA, so what will happen? Now TA will be off. The instant at which we give the triggering pulse to TA, at the instant at which we give the triggering pulse to TA, it will be on and TA will be T1 will be off. Now this is plus, this is 2VA, this is L, and this is plus minus VA. This is L, this is C. Now what will happen now? Due to this voltage, due to this TA short circuit, this capacitor voltage, now it is coming here 2VA. So the T1 is reverse bias now by a voltage of 2VA minus VS, and it will be off due to reverse voltage. So that's why it is called as a voltage commutation technique. And since the external supply is used to develop the voltage across capacitor, that's why it is called as an external pulse commutation. So now I am stop sharing my screen. My dear friends, whatever information I have shared in this video related to the class E commutation, I have discussed about its power circuit diagram. Its operation also will be clear to you. If you like this video, kindly press the like button, and if you feel whenever I make such kind of videos related to power electronics, a notification should reach to you, then don't forget to subscribe my channel. Thank you.